Okay, this is number 2 from section 2.3. It says determine if the matrix below is invertible. Use as few calculations as possible. All right. Now I want to use a variation of the inverse matrix theorem. And remember, the inverse matrix theorem says that A is invertible if and only if A equals 0 has only the trivial solution. But there are actually different variations of that theorem. And another variation of that theorem says that A is invertible if and only if A transpose is invertible. A transpose. And remember, that means you switch around the rows and the columns. And I think it's much easier to show that the transpose of this matrix is invertible than the original matrix is. And let me prove that to you. If I find the transpose of this matrix, what was a row becomes a column. So 5, 0, 0 turns into column 1. Row 2 turns into column 2. Row 3 turns into column 3. But notice we have 3 different pivot rows. So that means that these are linearly independent columns. Or another way to look at it is, if you consider this matrix, I guess I could call it A transpose, this equation will only have the trivial solution because these columns are linearly independent. So because A transpose is invertible, so is A. So it's just a different variation of the theorem. So that's how you prove that one is invertible, or at least one way to do it.